Problem, we are given that triangle ABC maps the triangle A prime B prime C prime after reflection over the line y equals x. Let's go ahead and create triangle ABC in the coordinate plane. We can put triangle ABC anywhere that we want to. It wasn't specified in the problem. So I'm going to place A at 3, 0, B at 6, 0, and C at 4, 3. 3, 0, 6, 0, and 4, 3. We've now created a triangle ABC. We're going to reflect triangle ABC over the line y equals x. So let's go ahead and graph the line y equals x. And let's go ahead and reflect using our function rule f of xy equals yx. So a prime will be at 0, 3, b prime at 0, 6, and c prime at 3, 4. This is just to give us a visual idea of what's happening so that way we can look at these properties and know if they can be concluded. All right, now we have triangle A prime, B prime, C prime. Let's go through our properties. Angle A is congruent to angle A prime. Angle A and angle A prime are corresponding angles, and A prime resulted as a reflection, and a reflection is a rigid motion transformation or isometry. So our triangles are congruent, and since A corresponds with A prime, we know that those angles are congruent, so that is true. Segment BC is congruent to segment B prime, C prime. So segment BC corresponds to segment B prime, C prime because that segment BC mapped to B prime, C prime. And again, it was a result of a rigid motion transformation. So segment BC is congruent to segment B prime, C prime. Triangle ABC is a right triangle. We don't know that triangle ABC has to be a right triangle. It didn't specify that in the problem. And actually, the example that I used, triangle ABC, was not a right triangle. So that is not a conclusion that we can draw. The slope of segment CC prime is -1. So segment CC prime connects points C and C prime, and we know that that segment connects the corresponding pre-image and image in a reflection, and we know that that segment has to be perpendicular to the line of reflection. So my slope of y equals x is 1. The slope of CC prime is -1, and that must be true since this is a reflection. The midpoint of segment B prime is on the line y equals x. So if I look at segment B prime, I know that the midpoint of that segment must lie on the line of reflection, since the pre-image point and the image point are equidistant from that line of reflection. So that must be true. Triangle A prime, B prime, C prime is larger than triangle ABC. This is not true because triangle A prime, B prime, C prime was the result of a reflection, which is an isometry or rigid motion.